program underway. I think it's a very interesting one this evening. I'm George Abbey, a senior fellow at the Baker Institute for Space Policy, and I'd like to welcome you all to the Baker Institute. This is the first evening of a three-part program where we're going to be looking at the space program, the past, the present, and the future. This year has been a very difficult year for the space program, with the loss of Columbia and its crew on February 1st. So I think it is very timely for us to look at where we have been and where we are and where we're going. This month and this year are very significant historically. This is the 10th anniversary of the Baker Institute since its establishment. And on December 17th of this year, it'll be the 100th anniversary of the Wright brothers' flight at Kitty Hawk, which is another very significant milestone. But this year also marks the 35th anniversary of man's first flight out of Earth orbit, Apollo 8, which occurred back in 1968. And I'm sure many of you who were able to watch television remember that very memorable Christmas Eve with the crew reading scripture as they circled the moon. Great event. Our speaker this evening did not make that first flight out of Earth orbit, but he made the second flight to the moon 5 months after that flight in May of 1969. That was the fourth flight of the Saturn V. And on the second flight of the Saturn V, we had a number of problems. We had two engines shut down prematurely in the second stage on that flight. We had a very violent longitudinal oscillation. And after we separated from the second stage, we did burn on the third stage, but we were unable to restart the engine on that stage. And we needed to do that before we flew to the moon, because that was what really got us out of Earth orbit. That occurred in May of '68, and 7 months later we flew, that was an unmanned flight. 7 months later we flew a manned flight out of Earth orbit to the moon. That was done, as I say, 35 years ago, and I'm not sure in today's environment whether we could really do that again. But we were able to come up with the fixes that we needed to make to the vehicle and go ahead and commit to fly that flight manned, as I say, 7 months after that occurred. And our speaker this evening, as I said, flew the second flight to the moon. On that first flight, it was just an orbital flight around the moon with a command module, and we didn't have a lunar module. The lunar module, of course, is what we needed to have in order to land on the moon. The speaker's flight did have the lunar module with it for that first time, and Tom Stafford and Gene Cernan, who flew with John Young on that flight, separated from the command module while John orbited the moon and descended to a low altitude over the surface of the moon, not landing because the vehicle was too heavy to do the liftoff. But they were able to check out the lunar module in lunar orbit. And we were then able to do a flight to the moon and land on the moon 2 months later, 2 months after John flew in July of '69. Our speaker, I think, has had a very distinguished career, both as a naval officer and an aviator, and certainly as an astronaut as well. He graduated from Georgia Tech in 1952, and he saw service in the Korean War, both afloat and on shore, as a gunnery officer on the USS Laws. And so after that wartime service, he then went back and went into flying school and received his Navy wings, and then flew F-9 Cougars and F-8 Crusaders. F-9 Cougars off the Coral Sea, and flew also on the Forrestal with the Crusader. He then entered Navy Test Pilot School and had a very distinguished career as a Navy test pilot. He has set the record for time to climb in the F-4 Phantom. He did a lot of the primary work, flight test work on the Phantom before it went into the fleet. And as I say, held the time to climb record both to 3,000 meters and also to 25,000 meters. In '62, he came into the space program as an astronaut, and he has been an active astronaut for longer than any other individual in the program since '62. So that's 41 years now, a long time in the space program. And so John has really seen it all. His first flight was on the first flight of the Gemini spacecraft, 3 orbits of the Earth with Gus Grissom. And then he subsequently flew another Gemini flight as a commander. And then he backed up the crew that flew the first Apollo vehicle, and then flew the second flight to the moon on Apollo 10, and subsequent to that time flew as a commander on Apollo 16. So he's had 2 trips to the moon, and on Apollo 16, as you'll see, had a lot of surface time on the moon. He also flew on the Space Shuttle. The Space Shuttle flew initially in 1981, and we had previous to that time flown most of our test vehicles unmanned. The Space Shuttle was flown manned on that first flight, and John was commander of that flight, and it was a very successful mission. And then he subsequently flew as commander on the first scientific mission that we flew, the Space Lab mission on STS-9. So he's had quite a distinguished career flying in space, and has flown 6 times, and if you count the time he had lifting off the moon, he's actually had 7 flights. But certainly has had a very distinguished career. And so it is a great honor for me to be able to present my good friend and a true American hero, John Young.
Well, thank you very much, George. George's talk is a lot longer than mine. It is very nice to be here and to talk to you a little bit about space flight, what we've done in space and what we're going to do. You know, the National Aeronautics and Space Administration, our job is to expand human knowledge of the phenomena of the Earth, atmosphere, and space. And we've been learning a lot over the last couple of years, and sort of like keeping it under our hats, because it's pretty interesting what we found out in the past couple of years. We found out a lot of new things. We're also supposed to be improving the usefulness, performance, speed, safety, and efficiency of aeronautical and space vehicles. That involves making a lot of progress in the aeronautical and space field. And that's the National Aeronautics and Space Act of 1958. And it's a law. So it requires, the Congress requires us to make real progress. And I kind of joked to my buddies that we're going to get put in jail for not making real progress by violating the law, because we haven't been going very long lately, and so we got to do a lot better, I think, over the future, and maybe that's coming down the road. Somebody said the president was going to say something about a real space vision. I sure hope he does. But they said don't say what he's going to say. I don't know what he's going to say. Well, let me show you these slides of the past and tell you a little bit about the future, because I think in our life's history we're going to have a lot of fun with this exploration of space. I sincerely believe that the human exploration of space is the most important program going on in the United States today, and I'll try to leave you with the reasons why. This is the first flight of, you may have to dim the lights a little bit so y'all can see it. This is a Gemini 3 with me and Gus lifting off, and we learned a lot on the first flight. We staged quite high because they didn't know what the aerodynamics was supposed to be just quite right, and we also, at main engine cutoff, we got 7 Gs through the chest. We'd already proved that you could fly on a centrifuge up at Wright-Patterson. You could actually control a vehicle flying with 15 Gs through the chest, and although it hurts a little bit, you don't gray out, and you can still control the vehicle, which is pretty important. Well, that machine gets to orbit in 5 minutes and 30 seconds. And fortunately, you're breathing pure oxygen, so you can hold your breath for 5 minutes and 30 seconds. This is the first spacewalk done by my good buddy Ed White, and we'd practiced a lot getting in and out of the vehicle, and we found out when we tried the Gemini flight in the altitude chamber that you couldn't close the hatch. When you were pressurizing your pressure suit, you brought the hatch down, but you were too tall to close the hatch, because when you sat in the seat, the suit pressurized and pushed you right outside. Well, That was me. I'm a short guy, 5'9", and Ed was 5'11" or 6 feet just about, so he couldn't close it at all. So we invented that. We invented this device right here that you can see in the picture, which is a little. It's a little mechanical advantage thing that the commander would reach out, pull that thing in, and close the hatch on the top of Ed's head, squishing him down in the vehicle. Fortunately, they did, too, because if they hadn't done that, Ed would still be up there floating around. And we did the first rendezvous in space in the Gemini program. This is Gemini 7 and 6. Gus and I backed up the Gemini 6 mission with Wally Schirra and Tom Stafford in their rendezvousing with a 2-week-long mission that Frank Borman and Jim Lovell were on. It was really a really horrendous mission, and it proved that docking rendezvous could be done real easily in space. This is this Jim Lovell and Frank Borman as they got back from their flight, and you can tell they've been up there for 2 weeks in space, and they're standing up and walking around just like normal, which is really great. Everybody was worried that you wouldn't even be able to stand up when you got back from being 2 weeks up there. But they're now about twice as far away from each other as they've been the entire 2 weeks while they were up there. I won't say that Gemini was close quarters, but it was pretty close quarters. This shows a picture that we took on Gemini 10. We fired our motors, and when we're docked with the Agena spacecraft, and it boosted us up to 414 nautical miles. And we went through the South Atlantic anomaly. And the South Atlantic anomaly introduces a lot of radiation into your body on board the spacecraft, and in fact the report kind of brags about it. They brag about how the Gemini 10 guys got a lot more radiation than the Gemini 11 guys did, because they went up higher, but they weren't in the South Atlantic anomaly. Well, since I was on Gemini 10, you know, my nose still glows in the dark. And this is a picture that was made by Pete Conrad and Dick Gordon, and they're really up there, really high, and they're not in the South Atlantic anomaly, and they proved for sure in the Gemini program that the Earth is round. That's good old India, and it's really beautiful. Shows everything. It's a great shot. But the Gemini program showed that we could do what we had to do to make it to the moon, that we could operate vehicles in space, that we could do extravehicular activity, we could do rendezvous and docking, that we could use motors to change our orbit around, that we could do lift and reentries and make it back and landing. Matter of fact, on Gemini 3, the first entry on Gus Grissom was flying the vehicle, and we had a lift-to-drag ratio that was reduced by about 31 or 32% for a couple of reasons. One, the wind tunnel tests weren't any good at that stuff, and then the second was that they'd had the center of gravity in the wrong place, so it was 31% short. We were going to land 192 miles short, 192 nautical miles short, and Gus made it all up but 60 miles. And when you're flying with a lift-to-drag ratio of about a brick, that was a heck of an achievement. But anyway, that's what Gus did, and so that proved that the vehicle would work, lift and reentries, which you needed in the Apollo program. We also proved all the things that you need to do to last for the entire 2 weeks, which is as long as the lunar mission was going to be. And we proved out in the Gemini program we could do that. And we also developed a whole host of people in mission control that could really well operate the vehicle, and it was really necessary. So the Gemini program didn't last forever. It just lasted a couple of years, and it was over with. And then we went on to this program right here, the Apollo program. It's a great program. Now, how many of y'all saw the movie Apollo 13? Y'all saw that? Yeah, well, this vehicle shakes quite a bit, but it doesn't shake near as bad as the one in the movie Apollo 13. Thank goodness I wouldn't have got on it if it had. It's a very nice flying machine. It's about 365 feet long, and I'm sure y'all have seen it out there at Rocket Park sitting around. They're going to refurbish that thing out there so it doesn't get rusted away, and it'll put 55 tons into translunar insertion. 55 tons. That's a lot of weight. And on top of this particular one, there's 3 very nervous human beings, Charlie Duke, Ken Mattingly, and myself. We're on the way to the moon on Apollo 16. Now, this is what the planet Earth looks like after you've added 10,000 feet a second and you're headed out for the moon. There are about 3,500 people on this planet that belong to a group called the Flat Earth Society. And they think that this is all done with mirrors and that the Earth is really flat. And I think they ought to look at this picture because I think that upset their theory somewhat. It takes about 2.5 days to get to the moon, and we did get there, and this is what it looks like up there. It's quite remarkable. You can take your thumb and cover up the Earth, and all you can see looking at the Earth is the white of the clouds and the blue of the atmosphere and the ocean. You don't see any of the continents. And sometimes when you look out the window and see the Earth out there and you're thinking, well, here I am 240,000 miles from the house. I wonder what I'm doing up here. But it's a great place, and on the back side of the moon you can see the craters up there. Some of them are bright red craters, and they're just brand new, and they're just beautiful, brand new craters. We don't know how old they are, but they're out there, and they're talking to us. Unfortunately, we're not listening. We did land on the moon up there, and this is what the picture looks like. The shadow of the lunar module is up there. You can't see it from here because this is a compressed slide, but by looking at the shadow, the footprint of the lunar module is 10 meters across, so you can see how big the craters are as you're coming down the land. It was required to have a radar altimeter. You really didn't need a radar altimeter. The human eye is a great piece of machinery. It can see down into all those shadows and doesn't see shadows. It sees a dirt under a little cover, and I've never seen a picture of the moon yet that didn't have a shadow in it, but the human eye sees down in all those shadows, even in Earthshine. And so we could land on the moon, and that's what we did. We land up there. It's a beautiful place where we landed. Now, the people like living and working on the moon because in 1/6 gravity, that pressure suit and I weighed 360 pounds, and you could jump straight up 1.5 meters off the ground, just easy. And that's about what we're doing there. And, of course, you only weigh 60 pounds when you do that. And you could pick up an equivalent of a 100-pound sack of moon rocks and jump up to the second rung of the lunar ladder, which is as high as this podium right here, flat-footed, and never even bother you. So when we go back to the moon, people are going to really like to live and work up there because the environment is so enjoyable. Now, one of the strange things about the moon is the temperature extremes. In this shadow right here, it's minus 100 degrees Fahrenheit. In the sun, it's about 120 degrees Fahrenheit, and before we left up there, it was 190 degrees Fahrenheit. The scientists had argued long and loud that we're going to find nothing up there but rhyolite volcanic rocks at our landing site, and they'd done that from photogeology. And when we got there, all we found was anorthosites, breccias, and norites that are very unusual rocks, and it's very old rocks too. The rocks in our landing site were 3.92 billion years old on average, and some of them were age dated in the 80s at 4.2 to 4.5 billion years old. So it's a very old place, and it's really is not what they expected we're going to find. And of course, they argued with us that we didn't know what we were looking at all the way back from the moon, and they kept telling us we didn't know what we'd seen. Of course, you know, you take two fighter pilots like me and Charlie Duke, and you train them a lot on geology, but they really don't know what they're looking at. So I said, why don't you wait till you get these rockbacks and take a look at them. Turned out we guessed right. And we put this lunar science station up there. This is a radioactive thermal generator that powered it. It's right there. It's really remarkable. It operated for 5 years after Charlie and I left, and this device sent data back to planet Earth through this thing right here. And of course, this is a passive seismometer, which we put out there on the surface. It measures moon quakes and moon impacts. You could sit forever in this room and never feel a moonquake. Moon impacts rang the moon like a bell. It turned out it measured 3,000 events a year, 500 moonquakes and 2,500 moon impacts every year. Turned out it was the most sensitive device that was put on the surface of the moon. You know what the principal investigator told us about it? He said, if you don't put my experiment out right, he said, don't come back. That's probably why it turned out to be the best one. We did put the first telescope on the moon. It's a beautiful thing. And the moon is a great place to have telescopes, and I'm sure that one of these days we'll put a great big telescope up on there on the moon to keep an eye on our own planet. And this is the first one. This is done by Dr. George Carruthers at the Naval Research Lab, and it's ultraviolet measuring camera and it took this picture of our planet right here. These are oxygen-rich equatorial air globe belts, and there's the North Pole and the South Pole, and you can see the entire surface of the summertime or wintertime, you could see either North Pole or South Pole completely. So I think a big telescope on the moon one of these days will be useful. Now, the administrator was really overjoyed when he got this picture back because it made the front page of the Washington Post. You know, the Washington Post is a newspaper that all the congressmen read. And they were bad-mouthing the Apollo program, saying how much money it was wasting and how much it was taken away from people who needed feeding on the planet, which is not really correct, but that's what they said. And it made the administrator overjoyed that he'd get a picture like that in the Washington Post to help him out. I don't know if that helped him or not, but he thought it did. We had this rover that we developed to drive around on the moon. It looked like this. It's about as big as a small Jeep, and it has, I have work on this handle with the Marshall guys. It has right and left and forward and aft and stop and go and set the park and brake all in one switch. So it's now one of 30,000 space spin-offs that allow people who are disabled to drive safely, even out there on Main Street. I wouldn't try it, but they say it will. Anyway, so, and it was a very interesting driving machine. If you drove too fast, about 7 or 8 kilometers an hour, and cut the wheels, you'd slide out and go backwards. You know, just like driving on ice because of the low gravity field. But you know what saved us? There was nobody coming down the road from the other direction. One of the things that everybody's going to be worried about when we go back to the moon is dust. It was really all over the place, and it got in everything. And it's not your average kind of dust. It's impact dust. So it's sharp, like little bitty razor blades, tiny razor blades. You wouldn't never want to breathe that stuff or to really wipe out your lungs. So we use it all over the place. And I think when we go to the moon and Mars, dust is going to be one of our main problems. We'd done 3 extravehicular activities, and our wrist wings were just about to bind up where you couldn't move them, because of the dust was impacting into the wrist wings, and we didn't have them covered up. You can see in these pictures, you can see the good old wrist wing right there. In later flights, they had them all covered up, back up to their elbow where they wouldn't get dust on them. I mean the next flight, excuse me. And one of the things about the moon that's really interesting, this is the North Rae Crater right here. We had a map, so we knew where we were all the time. This is North Rae Crater. It's a dimple crater. It's about 900 meters across and 200 meters deep. They wanted a picture of the bottom of it. So I said, well, give me some rope so I can crawl over there and take a picture looking down the bottom. And they said, no, you can't have rope because rope won't work in a vacuum. Well, I hate to tell you, but rope don't know whether it's in a vacuum or not. But I never could get them to give me any anyway. And one of the things about it is this is me, and that's House Rock right there. And how far away do you think it is? Well, it's enormous rock. It's about 30 meters high, and it's about 120 meters long. You can't see the long part right there, but we are 200 meters away from it. Really hard to tell. The reason you can't tell how far things away are on the moon is you just have nothing to reference them to. I mean, we don't have any telephone poles up there yet. We got to work on that. And there's a liftoff from the surface of the moon. Well, how about that? That's upside down. Okay, there's the lunar module right there, and we took off and we're going this way. That'll kind of hurt you if you hit the rim of the crater. Anyway, so there's the lunar. There's a descent stage of the lunar module. There's the wheels. There's the tracks and footprints all over there, and there's the good old rover sitting right there. And the scientists say that those tracks and footprints will last forever, for millions of years. But I think that one of these days, next 20 or 30 years, that some civil engineer is going to want to put a freeway right through there. And I think they'll do it, too, if the Lunar Environmental Protection Agency will let them. Well, this is another picture that's sort of upside down. I hate to tell you. People don't know upside from right side up. Oh, well, this is north going this way. There's Maury Martinus and Maury Smithy. There's some craters on the surface of the moon that are really awesome. You can't really see them all here, but one of them is 77 kilometers across, and this is the back side of the moon, the part you can't see. So you can't see this part from the front side of the moon, and if we did see the front side of the moon, we'd be far more appreciative of impact processes. Here's one right here. That's King Crater. It's a beautiful shot, and And King Crater is 77 kilometers across. And how big is that? That's about as far as from here to Galveston. It's a big crater. So if that hit the planet, it would wipe you out. King Crater was one of about 30 bright red craters on the backside of the moon that Gene Shoemaker wrote in one of his last papers, along with craters they discovered on the Earth, that planetary impacts on the surface of the Earth have increased, doubled over the last 300 million years. Now, we think that we've found, NASA research has sponsored, and we found that the last 4 major extinctions on this planet were caused by cometary or asteroid impacts. There's a lot of controversy about that, but people think that's a possibility. And right now, the given statistic of an asteroid or cometary impact destroying civilization in the next 100 years is 1 in 5,000. That's pretty high-risk odds considering it's a risk of civilization, but that isn't half of it, because that isn't the only thing that you have to worry about when you're on planet Earth. Well, what else do you have to worry about on planet Earth? Well, there's some of the stuff right there. Volcanism. It's all over the surface of the Earth. There are the Messier craters, which you can see with a pair of binoculars, and you can see we beat up the back end of our ship pretty badly there. But these are very old volcanic events right there. But on our planet, they're not quite as old. Now, we did do 6 missions to the moon. My wife worked for the people who did the probability risk assessment of going to the moon, and she said she told me that the probability of the Apollo 16 being successful was 1 in 5, and so that's a pretty high risk event. And Bill Anders told me that on Apollo 8 he thought his chances of getting back alive, because they only had a command module with no lunar module, was about 1 in 2. And I don't know if that's right or not, but it sounds right. Anyway, my wife said she told me it was 1 in 5, and she said I blew it off. I don't remember her telling me anything like that. Well, we had 3 seismic stations up there, and it was telling us what our risk was for impacts, and we shut them down because they didn't have enough money to keep them operated. So, but we did put up there the Lunar Rain and Retroreflector network that's up there right now, that we know the distance to the moon and how it oscillates to centimeters tracked from Earth. It's a great picture of the moon. It too is sort of like, okay, which way is north? North is up that way, I guess. Anyway, there's Maury Marginus and Maury Smithy over there but it's a great place. And down there at the south part of it is the South Pole Aiken Basin, which you can barely see right there. The South Pole Aiken Basin is a remarkable feature on the surface of the moon. It's really amazing, because the South Pole Aiken Basin, they believe, is water down there at the south poles of the moon. Some people believe lunar prospectors found that out, and maybe Clementine found that out. And there's rims on the South Pole. There's one rim on the south crater of the South Pole called Shackleton that is in the sunlight 98% of the year. So it'd be a good place to put solar rays if you're going to send electricity back to the Earth. And one of these days we might have to do that. Now, this is our good old planet. I was just going to tell you about some of the things that's going on this planet with respect to volcanism. This is a great shot. It's probably the best handheld picture ever made of the United States. We took this on Apollo 16. Right out here is one crater, the MS crater, that has a tuft, has a rhyolite tuft on it, and there's Yellowstone up there with a huckleberry tuft, and then Long Valley Caldera is up there, actually in the daylight, which is got the Bishop tuft up there. Those are supervolcanoes. Is anybody here familiar with supervolcanoes? Anybody ever heard of a supervolcano? You know what one is? Well, it puts out more than 1,000 cubic kilometers of ash in the stratosphere. And when it does that, the temperature in the temperate zones around the world go down below freezing for several years in a row. The last supervolcano was Toba in Sumatra. It put out 2,800 to 3,000 cubic kilometers of ash, and the temperature did go down below freezing for several years in a row, and the human race narrowed down to several thousand people. And that's why, strangely enough, human beings pretty much have the same DNA. There was an article in Scientific American the other day that said there's no such thing as race, although there are idiosyncrasies among so-called races. Well, actually what it means is we're all kin. I know y'all didn't all want to be kin to me, but it's too late now. We're all kin. We belong to the same gang, the human race. That's our gang. And that's the way it is. And that's the way the solar system is. And how often do supervolcanoes occur? Well, they occur once. You get 2 of them every 100,000 years. There was an article in the London Times about 5 years ago that was bragging about how are we living on borrowed time, because Toba's the last one that we know about. Yellowstone goes off, according to the guys that look at Yellowstone, it goes off every 600,000 years. Well, when's the last time it went off? Well, I know you don't want to know this. It was 640,000 years ago, so it's overdue. And there's an article in Popular Science the other day that this guy was bragging about how he's going to forecast a catastrophe when Yellowstone goes off. Well, we don't need to be able to forecast catastrophes. We need to be able to accommodate them. Supervolcanoes and asteroid and cometary impacts are the way the solar system and the Earth has evolved. It's just the way it is, and there's not much we can do about it right now. But I'll tell you, if we develop the technologies that we must have to live and work on places like the Moon and Mars, when those things happen, we can do something about it. And I'll tell you about some of those technologies. Well, we did get back from space. We're flying there, and we're coming back to enter in at 7,000 degrees Fahrenheit there, and that temperature. And fortunately, the thermodynamics are conservative, and it's only 68 degrees Fahrenheit in the cockpit. We did manage to land in the ocean, struck it with a great force, and didn't hurt anything. And there's the helicopter coming to pick us up, and of course we had the whole U.S. Navy waiting for us, which wasn't too bad. Actually, we had a Polaris guidance system in there, so it could land within about a mile of the ship. And actually, if you wasn't careful, it'd land on the ship, so we were very careful about that. But it was a great mission, turned out very well. There you see the three survivors of that mission. We had more than 99 problems that we had to solve in real time, both with our help and the help of Mission Control. Mission Control's people came and helped us solve one problem. We didn't know whether we were going to be able to land or not because one of our thrust vector control systems on the command module wasn't working properly. It was oscillating, and they found out it would be okay for us to go down. I thought for sure we were going to have to abort the mission, and we ended up bringing about 200 pounds of moon rocks back. But we did solve 99 other problems with the help of Mission Control and doing it ourselves. And that really is what life is all about in a teamwork activity, is solving problems in real time and being successful. But here you see these people have been up there for 11 days, 3 of them, and they haven't had a bath. So these sailors are starting to move out. We did start to work right after we got off this mission. We started to work on the good old Space Shuttle, and Captain Crippen and I got to fly the first one back in 1981. It's a remarkable machine, and we learned a lot of things on the first flight, and Dr. Kraft said it best. Dr. Chris Kraft said it the best. He said, we just got infinitely smarter when we got back. We did learn a whole lot of things, like we staged 10,000 feet high because they didn't know what the normal forces were. They didn't have big wind tunnels. We had real gas effects that messed up where the elevons were on the way back, and we had some oscillations going through Mach 1.6, and we landed real long because the drag was the drag of the tiles was overestimated. But all in out, considering it was the first mission where we didn't really know what we were doing, but we did it anyhow, it worked out very well. And we did land out there, and we were shooting for 185 knots, and we hit it 184.6. The height of eye in this thing is farther than you can see with 36.5 feet up to that place right there. So you can't really, you have to practice a lot. We had a shuttle train airplane where we practiced a lot. That height of eye thing would get you. And we were going to use the radar altimeter, but the radar altimeters, both of them locked up on the landing gear, so we didn't have a radar altimeter, so we had to gauge it. So it came out all right, and we're very proud. Bob Crippen and I were very proud to make headlines in the newspapers like this. And that's what we did, supporting the many hundreds of thousands of people that worked on this program and made it work right. It'll haul, right now, we've got it upgraded so it can haul 20 tons up to the space station. And that's a lot of weight to be carried to the space station, and it's doing a good job. And right now we're in the middle of working very hard to fix it up so we can go fly again as soon as we can, but I don't think we're working hard enough. We should be flying sooner, I think. But that's just my opinion. And the space station is up there right now. It's a remarkable device. Mike Foll and Sasha Valery up there right now doing work. I'll say only one thing about one of the things that's on the space station. We're using a bioreactor up there that was invented, and there's more than 600 or 700 of them being sold around the world, and the bioreactors can operate in zero gravity, and they turn cells over, and they can develop tissues in 3D. And I think one day when we learn what the proper amount of shear forces are, we'll be able to develop things like body parts for human beings using this thing, and it'll really be remarkable. And they also talked about using it to develop the islet that you can inject into the pancreas to avoid diabetes. If that comes to pass, diabetes is a $50 billion a year problem of the USA. It'd sure be good to solve that one. Everybody's been worried about it. But Mike and Sasha are up there right now working away, and they're doing a great job. And, of course, the progress, when you take the progress up there, you can't haul a whole bunch of stuff up and bring it back, so that's people are worried about it. And people are worried about the air they're breathing, but I think the guys up there aren't worried about it much because they think it's okay, and they would notice if there was any difference. When we finish with it, it's going to look like this. Space station it'll be a tremendous feature. It looks like a big tinker toy, but what it really is software. There are more than 3 million lines of codes in there right now. And just like your computers on the ground, how many have ever had their computers crash while they're using them on the ground? Anybody here? Probably no one here, right? Okay, so, well, they do crash in space every once in a while, and it gives you interesting problems that can be solved. And fortunately, the Russian part is totally separated from our part, so when our computers crash, they can take over, and vice versa. When their computers crash, we take over. So that works great. And contrary to popular opinion, the control moment gyros, there's only one of those bad. They said in the newspaper that 2 of them are bad, but they're not. They're in good shape, and so I think the vehicle is going to be operating. When we get this experiments up there, I think using zero gravity will be a very interesting thing, and I'm sure that things like protein crystal growth, where you develop proteins and find out what their properties are, that you can't really find out on planet Earth because you can't do them to the level of angstroms you need to measure them at, will really be remarkable advances in things like drug development. One fellow told me that he thought he was pretty near to developing a cure for a pill to cure anthrax. He said it's going to be drugs that stop anthrax and cure it, and not vaccines. I hope he's right. Well, we're not going to stay on planet Earth forever. One of these days we're going to go back to the moon, and this is the North Pole of the moon, and that's a big thunderstorm over the good old. You can't see it. It's in the middle of Africa. Okay, so but I think the moon is in our future. And the way we have to get back to the moon is use heavy lift. This was done by the synthesis group that George knows full well about, and this is an actual Super Saturn V. It'll put 120 metric tons to translunar. That's just what you need. You need to put a lot of weight up there to get things going. You need to have reliable, uninterruptible power up there. When I returned to the moon conference, they were talking about a new megawatt transmitter using uranium up there that had about 150 meters of cold plates to operate properly, and I think that would be really great for starters up there on the moon, because you have to have reliable, uninterruptible power to do all the things you need to do when you get to the moon. One of the other things we need to do up there is to have large inflatable structures up there where you can grow crops and where people can live and work. And of course, all you need to do is dig down a couple of meters and you're in a storm shelter. You can set up a storm shelter, and I'm sure that people, when they go out operating, they'll have storm shelters. And there's solar rays up there on the surface of the moon. One thing about the moon is it has 2 weeks of daylight, so it'll be really interesting to put solar rays up there. One of the things we've been doing at the Johnson Space Center is preparing terraforming. A good crop of wheat, according to National Geographic, is 80 bushels an acre. Done this way and grown in layers, this is 1,070 bushels an acre of wheat, 75 days from seed to seed. This, of course, is going to revolutionize farming. They've already developed a fertilizer that if you put it on plants, up and down the Mississippi River. It's a regenerative fertilizer, so it wouldn't cause that die-off out in the Gulf of Mexico that's occurring right now due to oxygen. So I think it's already starting to help revolutionize farming, and it's just the beginning. Being able to live and work on the moon, you've got to be able to grow a lot of crops in a small area, and that's one thing, terraforming. And here, of course, I think the way we'll do it in the future is you'll have mission control centers that are in here, and they'll be operating micro rovers all over the surface, and when the micro rovers find something of interest, then the crew persons will suit up in this airlock and climb out and go look at them. They won't be out on the surface all day long, because operating in a pressure suit on the surface is probably hazardous to your health. But look at the opportunity we have right here. There are 2 vehicles. So right here we have the opportunity to have the first automobile wreck on the surface of the moon, right? And I was in a suit last summer that's a new pressure suit. It weighs about 100 pounds, and including the backpack, and you can bend over and pick up rocks. It's really highly mobile. There are new materials out there now. The pressure suit we have now that we wear on the Space Shuttle weighs over 300 pounds, and counting the safer, it weighs 375 pounds. This would weigh 100 pounds, including the backpack, and allow you to stay out there and operate and do all the normal things you do and not get coated with dust and everything. And you can see the surfaces. Each one of these things is covered with about 1.5 meters of dirt, so that protects it from cosmic rays and solar flares. And that'll be a moon base for sure. For sure. One of the things that's very important that we think about a lot is lunar solar power plants. One of these days, I'm sure that if we're going to the way the planet is, as somebody once said, it's kind of like Walt Kelly Pogo used to say. Pogo used to say, we have met the enemy and it is us. By 2050, it's forecast there are going to be 10 billion human beings on the planet Earth. Well, if 10 billion human beings in the developing nations are all doing what we're doing right now, which is burning coal to have coal-fired electrical plants and burning gasoline in all our automobiles, and the developing nations like India and China and the nations in Nigeria all want to have 2 cars in every garage burning fossil fuels, the effect of carbon dioxide on this planet is going to be incredible. And somebody could figure all that out, but it's going to be awesome. Well, one of the things you can do with a lunar solar power plant is to send back uninterrupted electrical power from the surface of the sun, because there's you can have an east base and a west base, and Dr. Dave Griswold at the University of Houston wants to do that, and send back reliable, uninterruptible electrical power forever to planet Earth through rectennas. And maybe that's the real way to do it, because we have got to stop using fossil fuels with so many people coming on this planet. Now, people don't think about that. Now, why shouldn't China have 2 cars in every garage if they can get them, huh? The Chinese. Why shouldn't they? They ought to. But let's make sure they're burning something that won't end up polluting the atmosphere so that we can't tolerate it. I think if the developing nations in 2050 are all burning fossil fuels, coal, gas, and oil, and the already developed nations are still doing the same thing and using energy the way we're doing it, the atmosphere around us will be pretty much unbreathable. So we've got to do something about it. And the moon, I think, has a potential to save us. It really does. When you build stuff up there, like I said, I was in a Return to the Moon conference, and I saw there was another paper up there where the guy wants to have solar collectors and generate energy in there and concentrate it and run Stirling generators and send back 5.3 trillion kilowatt hours per year to planet Earth from the moon. And doing that, and since the United States funds such a thing, the United States fund it, why, what could you do with the income you get from selling it to your neighbor for 10 cents a kilowatt hour? Well, you could do things like retire the national debt. That would be nice, wouldn't it? Those guys really think big when they write those papers, don't they? They haven't seen the national debt lately. Anyway, I think I sincerely believe that using the moon for solar power, for reliable, uninterruptible, reliable solar power that doesn't pollute, that's pollution-free, will be the key to the future of the human race. And we should get on about it, because we may not have a lot of time. And trying to convince everybody else to do that is going to be very difficult. But I still think it's worth a try. Now, why should we want to do that? Well, one of these days there might be a moon place that looks like this. You can see they're growing crops up there. Langley Research Center has built glass where you can shoot a 375 Magnum right through it, and it's self-healing. I don't know that that would work, but there would be storm shelters around there where people could go hide in there, and you can see they're growing these oranges up there. These oranges over there, right there, they're probably from Brownsville. I don't know. But anyway, I think one of these days the moon will end up looking like that. And then what do you do about one of these days? I'm sure we'll go to the Mars. This is the Franklin Chang's engines, a Vasimir engine. It has the ability, clusters of these engines could go out and if target comets or asteroids that were targeted to us, it could move them out of the way. And I think that's a common thing too, so we need to work hard on Franklin's engine. And if you had the right amount of nuclear power supporting it on these jobbers out here, the right amount of nuclear power, you could put people around Mars in 39 days, which is really moving. But it also, the beauty of that engine is it allows you to give very small thrust, because some of these asteroids are just rubble piles. You dock to them too hard and try to move them out of the way, you wouldn't be able to do it. But I think that's worth thinking about. And this is our good old planet right here. Now, and it's a great place. I wouldn't trade it for anywhere. But the risk to civilization for the next 100 years of either a supervolcano or a comet or asteroid impact is 1 in 455 per 100 years. Now, that's very high risk to loss of civilization. That's why we need to be thinking about the future and working on things that prevent us from getting hurt in the future. Developing the technologies that we need to live and work on the moon and Mars, reliable, uninterruptible electrical power, the ability to terraform under inflatable surfaces, and all the kind of things that I was talking about on the surface of the moon will certainly help us to protect the people on this planet. The NASA vision is to understand and protect our home planet. We understand the home planet, but what we need to do is protect the people on the planet, not the planet. Because the planet can take it. It doesn't care if it gets hit with a 200-kilometer diameter size asteroid or not. It just yawns and keeps right on going. But the life forms on this planet sure won't, unless they have the technologies that we need to have to live and work on the moon and Mars and other places in the solar system. I think by the middle of the next century, the transportation events on this planet will be such that we can probably evacuate half the planet if something so big is coming for us we can't do anything about it. We ought to be working on those kind of things. And I'm sure there are some very smart people that are, but we need to be thinking about that. And why should we be worried about such a thing? Well, this is something that everybody in this audience once was, and everybody in this audience I'm sure is going to have. You need to be worried about your children and your grandchildren. Now, these are my grandchildren, and it's very hard to see, but over Katie's shoulders is launch pads. I think their lives are going to be more challenging, more satisfying, and rewarding because of progress we make from those launch pads in space. Okay, I sure didn't mean to take up too much of your time, and I thank you for listening.
So we have some questions for you, John, that I will go ahead and read, and I'm sure you'll be able to answer them all. The first one I was going to give you, you mentioned living and working on the moon. Are you thinking of the model of the Antarctic stations?
No. Well, it would have to be a little more compressed than the Antarctic station. You'd not be able to go outside without a pressure suit on, and you'd not be able to. But the Antarctic station, I think, in terms of manufacturing capability and everything, when you live and work on the moon, to do things like develop solar power and stuff like that, people would be actively manufacturing. So instead of just scientific research, there'd be a lot of manufacturing going on.
Okay. How long were you in lunar orbit by yourself, and what was going through your mind at the time?
I don't remember.
You don't remember being in lunar orbit, or what?
I don't remember how long we were in lunar orbit, but well, we're just up there. We were just by ourselves while we're doing the lunar orbit rendezvous, and I forget how many hours that was, but I was really busy. You know, my job was to track the lunar module, and if their engine for some reason or another couldn't fire, I had to fire the reverse value in my engine, so I had to be ready to go, and I had to line the platforms and get the engines ready to go, and there were 40-something switches and circuit breakers you had to check to make sure you could fire the engine and stand by at every burn they made. If they didn't make it, I'd have to make a burn, and, you know, I was busy as a one-armed paper hand. Yeah. It's really nice when you pass behind the moon. It takes 2 hours to get around the moon. You pass behind the moon, everything goes quiet. It's really nice because nobody can say anything to you, and you can get a lot of work done. It's kind of like coming to work on your computer on Saturday or Sunday where nobody's there. You know what I mean.
What prospective mission or development in space technology excites you the most?
Well, I think the ability to live and work on the moon is a thing that I think it's going to be most worthwhile for the people of this planet over the long haul. I think the progress we make from our ability to live and work on the moon is really going to provide a lot of protection for the people on this planet. Just because of nature, you have to have 100% control of your environment. You have to be able to have 100% control. I mean, you've got to be recycling food, water, and waste, and you've got to be able to do that under a closed-loop environment with the right amount of power to do that. If you do that on the moon and then you can do that on the Earth, when bad things happen to the Earth, and they're going to, we just don't know when, we can do something about it. We don't have to sit around here and wait for the doom of civilization, which is what the damn statistics say we got to sit around and wait on right now. We need to work on that.
All right, well, here's another interesting question. The safest space program is not to have one, which obviously is not an option. How do we then determine what's the accessible level of risk?
Well, everybody wants everything to be safe, but it just is not possible. I think you just put good engineers working on it, and they take the risk out as much as they can. That's what we've done all along, isn't it? That works. I mean, I thought Apollo was very safe, but apparently it wasn't. It made it seem like it was. I think the big guys probably were ready to quit because they thought the scientific results wasn't paying for the missions, but I mean, it was hard to get money to fly those extra missions.
Well, speaking of money, NASA came up with a $400 billion plan to go to Mars. Is there a cheaper way to go?
You bet. Go to the moon first, and then figure out what you need to do to go to Mars. And that was a $400 billion plan. Was well, you know, it was price was jacked up about double or triple what the people had originally planned for it to be. You remember that? Don't you think?
That's true.
Yeah, so the guys were just trying to. Everybody looks at when you're going in and building a new program. Everybody looks at how much it's going to cost. Like I give you for example, George Lowe said they could go to the moon for $10 billion, and Jim Webb, who's a very smart guy, said, "Well, I'm going to ask for $25 to $40 billion." You put that in today's dollars, and it did it for $25 billion. You put that in today's dollars, you're looking at $125 billion right there. And that's probably about what it'd take to get back to the moon and put up a base. Although I just read in the newspaper the other day where they could do it for $10 billion. I don't know what they're smoking, but that's what they said.
What are your thoughts on the recent suggestions that the U.S. space program may revisit the moon?
Well, I think it's a great idea.
I kind of figured that you'd say that.
Yeah, I'm really all for it. I think we're going to learn so much when we get back to the moon that we don't have any idea. We sent these probes up there and we've looked around, but once you send people up there and start looking around, we're going to find out things we never even dreamed about. And like I keep looking at all the rocks we brought back. I wish I'd have had a magnet with me so I could have brought back some of the real. I know there's all kinds of rocks laying around on the moon that have been hit so many times by all these things. There's got to be iron and steel, and not steel, but iron and nickel and probably platinum up there somewhere. So, I think there's a lot of things we can be looking at on the moon. And if there really is water on the moon, of course, and you can you just electrolyze it, and you got hydrogen and oxygen, you can get to anywhere from the moon with 1/22nd the energy it takes you to get out of this gravity well here. So I think the moon would be a great advantage from getting from anywhere to anywhere in the solar system if there really is water up there.
Well, there are two questions that are very similar. concerning a mission to Mars. What are your thoughts on establishing a launch base at L1?
Oh, I think L1 is not a good idea. I think we ought to go where we want to go. L1 is a nice place, but I think if you end up putting a big base there, it's going to cost billions of dollars, and people are not going to be able to work there because there's lots of radiation there, and where do you get away from the radiation and the solar flares? And they're talking about putting this telescope out at L2, and I wish they'd put it on the moon, this Jim Webb telescope. But anyway, they're talking about putting it out at L2 and then fly it back to L1 and have people work on it in the kind of radiation environment that's at L1. I don't, it might be healthy, but it might not be. We don't know how to protect people from radiation. We're looking at new materials that protect you real good from radiation, some polyester stuff with hydrogen in there that's supposed to be very good, but it's still, there's solar flares out there that can cook you. If we'd have landed on the moon in August of '72, we'd have been cooked by a big solar flare. So I was kind of glad we went in April.
What do you say to the people that claim that the landings on the moon were not real?
They ought to take a look at the rocks. They're very dry rocks. They're very old rocks. You won't find rocks like that on Earth. And plus, look at all these gray hairs. Shoot. They don't think we did it, huh? Okay. I saw that TV show, and it was weird.
There has been a lot of discussion about the role of the orbital spaceplane versus upgrading the shuttle. What is your opinion on that?
I think the shuttle should be upgraded, and I think the orbital spaceplane needs to be built too, but I'd kind of hope they'd build my personal wish is they'd build a capsule so we could get out of low Earth orbit, because I really think getting out of low Earth orbit is very important to the future of the people on this planet, and going and learn how to live and work on places like the moon and Mars.
What do you think are the limiting technologies relative to getting back to the moon and Mars?
Well, I'm not sure the limiting technologies are limiting. We have, and I'm sure there's a lot of them at Rice. They have very smart young engineers that are looking at new things like nanotubes, and if you can really make really make nanomaterials out of it's 50 times stronger than steel and 10 times lighter or something, you can make materials out of that. Why, it'll be absolutely remarkable, I think, and that's what we ought to be, and all kinds of things. Supercomputers and things like that. There's really a lot of things we can do to improve significantly the technologies that we got right now, I think, that we ought to be looking at for using going back to the moon and on to Mars.
How would you compare some of the technologies that allowed you to go to the moon versus the new technology today?
I don't know as I could compare them. I don't see, it's kind of like comparing apples and oranges. Although, the Saturn V was a great flying machine, and you could probably do it today. I'm pretty sure they still have the good old blueprints over there at Marshall somewhere. We could probably pull those out and build Saturn Vs, and it'd be a great machine. I think Werner von Braun had the right idea, though. He test-fired every stage from start to finish to completion, every one of every vehicle. I was always grateful for that. And his engineers told him he didn't need to do that, but he did it anyhow. A pretty smart guy.
Do you have a concern about the number of people not going into engineering these days?
Sure do. I think engineering is a fascinating business, and I think engineering is really going to be interesting. But, like, for example, if the United States had a goal of going back to the moon, for example, just one goal, science and engineering in the United States peaked in the 70s after the moon program, and it has come down ever since. And that's because it took a lot of very smart, talented, and creative young men and women to work in this business to figure out new and better ways of doing things. And I'm sure there's plenty of new and better ways of doing things that I don't even have any idea about, that if we had creative, smart young engineers, and all you do is have to have the goal. And then you beat off scientists and engineers with a stick at NASA. You would have to beat them. It'd really be neat. That'd be like it was in the old days.
Well, that covered all the written questions. Are there any other questions from the audience?
See, they need to get some beer.
Well, we do have a reception immediately following right outside. So, John, thank you very much for a very good presentation, and appreciate you coming up to the Baker Institute and talking to us this evening. Thank you very much.
Thank you.